try to visualize an electron, a spinning electron. You must be seeing something, a ball, like a ball, which is rotating clockwise or counterclockwise, but something which is rotating. And this mental picture that we have, that an electron has spin this way or that way, it is physically rotating, is incorrect. Let me prove you how. We'll use some school level mathematics to prove that if an electron is really spinning, it would exceed the speed of light about 430 times. Let's begin. Okay, let's start with this normal size ball. Let's assume that it has same angular momentum as an electron. Now, given its size and its radius, the velocity at which this ball will spin is represented by V equals to L divided by M into R. M is the mass and R is the radius of this spherical object, ball in this case. We know what its mass is, we know what is its radius, and to get the value of L equals to h bar divided by 2. We know what is h bar, we get L to be 5.27 into 10 raised to minus 35 kilogram meter square per second. Okay, for a standard ball, the mass is about 50 grams and its radius is about 0.033 meters. So its velocity is 2.8 into 10 raised to minus 32 meters. That is insanely slow. Even if you have waited for a trillion years, you will barely see this moving. Okay, let's go smaller. Let's take a marble, a small marble. Now this would be at least 100 times smaller than a tennis ball. Its mass would be about 5 grams. Its radius would be about 8 mm. We know its mass, we know its radius. If we plug in these values, we get its spin to be 1.32 into 10 raised to minus 30 meters per second. Now that's 100 times faster than a ball, but still basically motionless for us. Now let's go even smaller. Let's take an iron ball, a small iron ball. Now its mass would be 0.1 gram and its radius would be 1 mm. We know what is L. We will get the velocity at which it will spin if it had electron's angular momentum to be 5.27 into 10 raised to minus 28 meters per second. Basically motionless. Let's go even smaller. Let's take the smallest thing that a visible eye can see. A grain of sand. Its radius would be 0.1 mm and its mass, we'll use this famous formula from our school days. The density is 2650 kilogram per metric cube. Plug in those values, we get its spin to be 4.8 into 10 raised to minus 23 meters per second, which is a billion times faster, more than a billion times faster than this, but motionless for us. Let's go atomic. Let's take the smallest atom that we know, a hydrogen atom. Okay, so the radius of an hydrogen atom as per Bohr is 5.29 into 10 raised to minus 11 meters. Now its mass is 1.67 into 10 raised to minus 27 kilograms. Plug in those values and we get its speed at which it will spin if it had electron's momentum to be close to 600 meters per second. That is 160 kilometers per hour. If we do a basic calculation, we will find it to be 0.0002% the speed of light. Okay, let's go even smaller. Let's go to a proton. Now mass of a proton is 1.67 into 10 raised to minus 27 kilograms. Its radius is 0.84 into 10 raised to minus 15 meters. If you plug in those values, you'll get its velocity, a proton's velocity if it had electron's angular momentum, to be 37,600,000 meters per second, or basically 37,600 kilometers per second. That's insanely fast. But how is it against the speed of light? It is 0.13 the speed of light, or 13% the speed of light. But hang on, there's a better way to calculate the spin of subatomic particle given by this equation. L equals to 2 by 5 multiplied by mass multiplied by its radius multiplied by its velocity. So velocity becomes 5 multiplied by L divided by 2 mr. Then that makes its speed, the speed at which a proton will spin, to be 2.5 times larger, which is 31% the speed of light. That's crazy. Now, What about electron? Remember, we started to find the speed at which an electron will spin. The mass of an electron is 9.11 multiplied by 10 raised to minus 31 kilograms. Now, what's the radius? We don't know what is the size of an electron because we can't spot it really. It's fuzzy, right? But let's go classical. The classical radius of an electron is 2.82 into 10 raised to minus 15 meters per second. Plug in those values. Now brace yourself. The speed at which an electron spins is 68 times the speed of light. And in more accurate version, it is 430 times the speed of light. 430 times the speed of light means either Einstein is wrong or our visualization of spinning electron is wrong. You see, electrons don't really spin physically. They can't. It has intrinsic spin, right? When you hear electron spin up or down, it is actually intrinsic spin. That's not physically spinning. Thanks for watching.